Hello, hello. Good afternoon to everyone here. Please take care of yourself, because I think now is the school season. A lot of you, not just your class, the other class is the same. So please take care, huh? But yeah. Okay, so I think you already got your assignment right back. You want to discuss assignment first, or you want to discuss first? Um, we can discuss assignment first if you want. And also there's a project. I think some of you wanted to start your project. Is it? I started already. Huh? So maybe we will talk about a little bit about project also. Um, so you want project first or assignment first? The others, eh? Any preference you want? Huh? Up to me. Okay, maybe talk about project first. Okay, project. So the project details is listed in the course info. So do you know where to find the course info now? I put in the week one. Week one, two, wait, hey, calculus two, and then you go, and then you go to course info. Okay, course info. Okay, and then inside this course info, you know what how many assessment you need to do, and then roughly what's the schedule. So maybe you will be worried that we are behind schedule. Actually, it's not, because some chapter will be longer, some chapter will be shorter. Okay, I'm following last year pace, last semester pace. So don't be too worried. Right. So this is the latex project you need to do. Okay. So in this latex project, what do you need to do in project one? So the topic is you design your own projects. So you need to find topics. Okay. So what kind of topics you can find? You can prove some measure, theorems or result that we use. Okay, or related. Okay, but I didn't do in class. Or you can think of some lemma that you think that is interesting or useful to prove. Or you can deal with these foundational knowledge. For example, the completeness of real number, the density of rational number, those things we are secretly using behind when we do limit stuff. Okay, convergence. So I mean, all these deserve. So okay, I think you guys are very worried about the mark, is it? So this the total is 10 marks. Okay. So this break into three components here. So I will mark based on your language, completeness of your presentation, and difficulties. So you can see the completeness of the presentation. Take out the most portion here. So what does it mean? This means that I I value your um I value your presentation more rather than rather than the nitty gritty languages. Okay or not? So you need to make sure that you build a nice story, write a good story about something. Okay, so this is very important for your presentation. Okay, later you need to do an oral presentation. Okay, for the next project. But for this one, I train you to write first. Okay, the completeness, and then the other one is language. Okay, so you need to have a proper language so that your sentence makes sense. Okay, makes sense to people. The last portion here is difficulty. Okay, so maybe you were wondering how to get this difficulty point here. As long as you did something extra than this class, you will get this difficulty. Okay, if you did something I did before, then you won't get too many marks from here. Okay, as long as you did something extra, okay, then this class must be extra. For example, what? Epsilon delta, we never do in this class. So if you did it, then it's an extra. Okay, no? Okay, so don't do something within our calculus to stop. Does it make sense? Anything I suggest you to do in project one, you can do because those are extra stuff already. Okay, so actually you should think of this project presentation as almost 3 marks for you. If you really put some effort and then try and cook something up, then this mark is for you. Okay, the hard part is about assignment and test only. Those are the part that test your academic. This project is just try to stimulate your learning and try to train your research skill. Okay, now does it make sense? Okay, so I think some of you have fixed your topics maybe. So once you go do a little research that you want to do, don't go full in first. Come and discuss with me first. Fix your topic, and then you go and do. Okay, we fix how to say a draft content that you need to work out, and then you go and work it out. Okay, don't finish everything and then come in. So this one is mine. Then if I found there's a major problem there, then you need to redo again. Then wasting your time. Okay, so this is similar to your FYP in particular. You need to every time meet with your supervisor, discuss what you learn and then what you achieve. Okay. Don't how to say don't try and not communicate with your supervisor and then at the end submit one thing that your supervisor thinks there's a problem, then you'll get really low mark, really low grade. Okay, no? This really happened last semester when I was a examiner. I'm not the supervisor. The supervisor is not happy with the FYP 7. Okay, so for 这个 project 你们一定要跟我讨论。OK， 如果不讨论的话，如果做不好就会被就会不高分，不要说把你掐掉，不会掐掉你。But anyway， 就是 you have to keep good communication with your supervisor. Okay, so this is a mini. It's like a mini, very mini, or a baby FYP. Why I say baby FYP? This one I just require to write 1.5 to 3 pages only. Okay, so what's the idea of 1.5 to 3 pages? I only require 3 sections here. So introduction, so and then the setup of your theory and then exercises to show how you use your theory. 3 parts only. If you imagine this 3 parts split into 3 sections, what do you get? You only get half pages for each. Okay, so don't try and write like 10 pages or 20 pages. That is wasting your time actually. At most you only get 10 marks only. Does that make sense? So you just need to demonstrate to me that you learned something new. Okay, and then introduce whatever new. Okay, not being introduced by me before. And then you need to prove maybe a theorem. And then give an example in the 3rd section then how to use this theorem. Okay. Yeah, that's enough. Okay. Okay. Yeah. Right. Any question? No question? No, clear? Clear? Okay, so because there are only very few people here, so we try not to clash topics. Okay, try not to clash topics. So once you found a topic, quickly find me first, and then I will try and list down what topics are given. Okay, even though some of you have messaged me or what, please remind me again. Also, okay. Then I will fix the topics for you. Then maybe the other have to choose the rest. Okay, no? Yeah. We try not to clash topics because in the end we will share this document and then all of you can study each other projects findings. Okay, so this is the purpose of these FYP or thesis, because we need to write it out so that people will study together. Because one person cannot study everything, right? You only have 24 hours. All people are the same 24 hours. So you cannot do everything. So different people do different things, then collab together, learn together. Does it make sense? Okay, no? Okay. Right. Cool. So we will discuss assignment. So let's discuss assignment. Maybe Jingyan you haven't submitted, right? Later we should talk about it. Okay. But you also can listen. But we can talk about it later about your case. Okay. So let's talk about assignment here. So you can bring out, your on assignment in your Moodle. I already uploaded yesterday night. So you can refer to your own feedback and then see that if I miss mark or miss count or you think that I missed something, after discussion you can come and see to claim mark or what or argue. Okay. So because you are first time writing this kind of mathematical assignment, right? It's not like calculation based. So I will focus on your argument. Okay, I will focus on your argument. So please refrain from writing all equation. Okay, you need to tell me how these equation got connected. Maybe by assumption you have this equation, then it follows that you have the other equation. Okay, it's not like equal, then done. Not like that. Okay, so try and learn how to write your argument from my solution here. I will also uploaded my solution, right? Do you know that? I uploaded in the Moodle. Okay, yeah. So try and learn how I write it. Try and learn how I write it, and then you can ask me if you are not sure why am I doing that. So let's start. So first question, right? I asked you to prove that Fibonacci sequence has an explicit formula for enter. Okay. So some of you just use this AN to prove it. Just use induction, like what we did in class. Okay. It is not wrong. Okay, it's not wrong. Just that why I give this hint here is that I somehow find this explicit term from scratch. Okay. Why do I say find it from scratch? Imagine you just handed a Fibonacci recursive formula here. How are you going to think if there's a connection between this Fibonacci sequence, like for example 1, 1, 2, 3, 5, 8, so on? How does it related to golden ratio? Correct or not? So if you follow this hint, right, it will demonstrate to you how this golden ratio appears. Okay, if you just use my answer and then show it, they are the same. Technically, it's not wrong. Okay, just that it's not clear where this explicit formula from. Okay or not? Understand what I say? Okay, so this is a problem about the nature of this solution. Let me just ask you a question. If you just show that these two, this Fibonacci recursive formula define the same formula as this explicit form, do you wonder how I get this explicit formula? Do you wonder? If you study mathematics, you should wonder. You really should wonder. Okay, so how I get it? I observe that this kind of polynomial, right, also satisfy Fibonacci recursive formula. Okay, and then I use if this Fibonacci, if this polynomial satisfies the Fibonacci recursive formula, then I can simply use the root to build my sequence. Okay, so this is how I solve it in this hint here. Okay, so if your solution if different from mine and I accepted your solution, right? Please also learn different solution. Okay, you will know how to solve things in different way. Does it make sense or not? Okay. Usually I will provide the shortest way. Okay, maybe sometimes you provide the shorter ways, but usually I will provide the shorter ways. Okay, so try and learn if it is different from your solution. Does it make sense? Okay, right. Um, I think this one still okay. About second one. Okay, second one, this one a bit tricky here. Some of you fall into a trap when you're using the hint. Okay, this hint only work for x as a scalar or a constant. You cannot put sequence inside this x here. For example, some of you use this limit as of n to infinity of n square root of a1 n equals to 1. You cannot use like this. Do you know why? Because this a1 n here is depending on n. It's changing. It's not a constant. But this hint says what? This hint says that x has to be a real number. It's a fixed real number. Okay, it's not a changing real number. Okay, so you cannot use like that. Okay, so you cannot use this. Okay, does it make sense? No question. Please ask if you have any question, don't understand what I say. Okay. I think I adjust my writing in my solution there. I didn't write this line here. Is it? Did you see my solution on Moodle? I didn't write this line here. Instead, I check the limit of these two first, the left and the right sequence, and then I straight away use squeeze theorem. Okay, because I don't want you to confuse. Remember that in my lecture last time, I mentioned that um, if if an less than bn less than cn, then it might not be true that you can just plug limit in all strict inequality, right? Remember that I gave this example here. Okay, if it is strict, it doesn't follow. It only follow when it is less than or equals to. Okay, so I want to be a bit careful. But I didn't take off marks if you write like that. If I take off marks, you can come in. I didn't take off marks, but when I write this solution, I try to avoid this kind of writing because maybe you think that this is true. Okay, this is not true. Okay, so this is not true. Okay, I gave you a counter example in the class, in the lecture notes. Okay, now, so remember, like the 1 over n greater than 0. But the limit of 1 over n is equal to limit of 0 sequence. It's not strictly greater. Okay, yeah. So I have a practice that whenever you use some assumption, right, you have to write it down. Okay, tell me where you use the hint, where you use the theorem. Okay, otherwise I wouldn't know where you use it. Okay, so this time I will be a bit stringent. Okay, if you didn't say by what, I will just take off marks. Okay, but in future, mm, whenever something is new, okay, there's some new theorem I want to use. What I want to see how you use it. You need to say where you get used. Okay, and then maybe for future question, maybe you can miss some theorem, for example, like property of convergence sequence. You don't need to say by property of convergence sequence. Maybe you just tell me, oh, because these two are convergent, so I can bring the limit in, or what, something like that. Okay, so it really depends. Depends when this theorem get used. If it's the first time I want to see how you use it, then you need to specify. But to be safe, obviously you just spell everything out. Okay, to be safe, you just spell everything out. Show me that you know it. Okay? Show me that you know it. If in the class you think I'm not clear, you need to ask me to do it. Okay, don't think that if I don't do it, then you don't do it. Okay, you need to catch me sometime because sometimes maybe I careless, maybe I forgot. Okay, it's not that I don't want to do. So maybe I think our class need to live in the principle we catch each other. Okay, so if I don't do it clear, if I don't do it rigorous, you need to question me. Okay or not? Yeah, you question me. Okay, all of us catch the principle rigorous. You can question me. Okay, if I say no need, then no need. If I don't say, don't assume me saying no need. Don't assume because maybe I careless, maybe I forgot. Unless I really say oh no need. Does it make sense or not? Yeah, we catch each other. Okay or not? Um, right. And then for question 3, I think most of you do it okay. Just that how detailed you do it. So I think what detail we need to confirm here. I think greater than 0 here just says that since every term is greater than 0, then all of them is greater than 0. But less than 1 here, maybe some of you show that it's less than 1/2, or some of you show less than 1. Then need some justification there. Even, you see, what I do here, actually, I skip inductive step here, inductive proof. Okay, so maybe this is something you can skip also. Okay, if you want to do it rigorously, obviously you need to use inductive proof because this is true for OM. But I think this is quite tedious. I mean, quite, how to say, not tedious, quite routine. Okay, routine proof. Um, yeah, I think the rest is okay. Actually, I'm quite happy to see your answer for this question because some of you you really found what is the limit of this sequence, which is 0. Some of you use a squeeze theorem, and then some of you, I think squeeze theorem, you use squeeze theorem. Yeah, you play around with this series here. I'm sorry, sequence. Last one. I think last one. I don't think this question is very hard. Okay, just that you need to understand what's going on. Okay, this question actually is not hard. What we use here, if you dissect what I use in this proof, right? What I really use is just a test of convergence. Okay, to tell me what happened to the limit of all the an and the property of limit of convergence. Just using these two things. But the hard thing is how to understand this an plus one, an plus r. I think this is the hardest thing here. Once you understand it, I think it's not too hard. Okay, no. So I mean, this is the first step. I guess first step is in LA, right? When you do general N proof. Did you guys prove for general N or not? For LA? Did you prove segment for general N? Yes, no, yes, no, yes, yes. Okay. So you need to try and get used to this kind of segment. Okay. There is no numbering and where there's no number. Actual number, I mean. Okay. Does it make sense? Yeah. See. Oh, okay. So there's one point I want to make here. When people do this, right, they only refer to limit of sequence. This is dangerous, you know. Limit of sequence, you cannot simply bring, it's not linear. It is only linear on convergent sequence. Okay, only when all of them are convergent sequence, you can split the limit. If it's not convergent, you never split the limit. Okay, so some of you write by the limit of sequence. Sorry, by the property of limit of sequence. Okay, which is not true. Okay, so you cannot. So let me write left of word here. So you cannot split limit for general sum. Sum or product or what? Or quotient or what else? What else we know? Scalar, multiple of sequence. It's not true for general sequence. Okay, only true for convergent sequence. You need to make sure every sequence inside is convergent. Then only you can split. Okay, now. So I will take off mark if you use this. So because you didn't um, take care about this convergence here. Okay, so convergence is really important in this case. Okay, does it make sense? Okay. If you don't believe, right, you can try and go find a counter example. Okay, whether it works for general sequence or not. Try and find a counter example. Whether you can just split them or not. Okay, try and find a counter example to convince yourself. Any question? Question? Do you think I'm too straight or not? A bit. Quite straight now. Quite straight. Still no. Ah? Straight what? Straight better. Oh, okay, okay. I mean, I think this is to prepare you to do proof later. Okay, otherwise, your proof will miss a lot of things. Okay, now. Now we haven't involved abstract concept yet. So we need to try and how to say, try and learn, okay, learn what is really going on behind your calculation. Okay? Then in future, when we look at abstract ideas, you already know how to write a basic proof. Okay, no? Yeah, we all learning. It's fine. Okay, we are all learning. Okay, no? Yeah, you will be better. Don't worry, because I already have students getting better. They are in my office hour. I want to promote my office hour again. So please come to my office hour if you don't understand my lecture. Huh? Yeah, later 3 p.m. Good. Later 3 p.m. just outside the meeting room. Okay? I gather all the top students from every batch to come, Those are the top students from like 2204, 2209, 2304. Okay, every batch is inside there. So if you have even your study problem or what you're taking ME future or university life or what you all of the you can ask them and not just limit to academic. Yeah. Maybe you ask them how you survive in Seng class. How you survive in Seng class. They all survived. They all took my class before. Okay, so yeah. You can ask them for advice. Okay, no? Yeah. So don't be shy. If you shy, you lose everything. Okay. Yeah. Don't be shy. And there's no loss or gain. Not losing. Okay, if you try to ask something, people, no one will scold you. Don't worry. Okay, do you have any question or assignment or other stuff, lecture stuff? Have you guys been doing the homework I gave you or not? The tutorial question and the lecture homework. Did you do? You must do. What Bing Chen say? 专职 assignment Uh-huh. So how your assignment goes? Think about that. How the assignment goes? Okay or not? Know how to do or not? Can find research on the question or not? Find any related material, unique discussion or what? 专子 you want to ask about 专子? Done already. I guess that one is the easiest, I guess. Question 4, number 2. What's that? Oh, racial test. Okay. Yeah. Actually, the series one is what I gave for my midterm last time. So I released to you now. Yeah. I mean, you have to do the tutorial question if you want to understand the concept better. You have to do. Okay. Don't think that I do this question, next question. I mean, in test will come out in this question. It's not like that. Okay. Is that when you do those questions, right, you will learn the concept behind. When I was learning linear algebra, right, we were studying the David Lake's book. Okay. Even though the question is not really like what is in the textbook, I finished all the questions inside the textbook. Yeah. What do? I'm the only one that sit inside the lecturer's office hour every week. Like tuition, one-to-one tuition like that. Seriously, I think for now, I think I'm really a bit embarrassed when I grew up, and then I think back because at that time, seriously, I don't have self-research skill. Meaning, why I think this is important? Because why I need a lecturer to like babysit me like that? Because our education is like we need someone to tell us what is correct. Only we think that that's correct. You understand what I say 吗？我们的教育系统把我们教到是说，需要有什么是正确答案，我才知道那个是正确答案的。谁知道那个是不是真的正确答案？你明白吗？ So I hope when you are in my class, right, try and develop your own instinct and try and find the logic to determine what's correct or wrong. Once you develop this, you won't ask me to check answer already. Because you know what is the right answer inside your heart. You understand? This is called growing up. Okay, you don't need people to tell you 什么是对，什么是错。你要自己决定什么是对是错。OK， 当然也不可以太固执啊。厦门有一种人是这样的，他觉得我就是对的，老师觉得他错，他还是觉得他对的。厦门有这种人，但是希望你们不是那种人。So you need to be open-minded， 听一听不同的想法，然后想一下，到底我真的有错吗？还是怎么样？能不能改一点啊？这点，Does it make sense？ 对。有人讲我考试太难，可能我也改一点哦，放简单一点哦，是不是？啊，OK， 还是太难。I mean must have， 为什么会难呢？我可以讲一下，就是它一定有一个 gap， 因为你们没有体验过那个 gap 先。所以等你体验过那个 gap 了我老实跟你讲我有一个读我3个学期的学生。那几个人5个人，5个人，他叫 NE 他们是差不多都是70以上的分，所以我在那个班已经是超标准了。如果我只教他们几个的话，它就是一个超标准的班，明白？所以我们要做的水平、水准是跟人家不一样的。OK 吗？If you want to stay at low level, it's okay. That's your choice. Okay, but don't scold me. 因为我们大家目标不一样。Okay, but I will bring you to a top level if you like, if you're willing to. 这样吗？明白吗？好 ，OK， yeah， 可以的，每个人都可以做到的，不是只有 IJ 做得到吧？真的，你可以有一天超越 IJ 的。 真的没有问题的，没有问题的。我有真实的经历的。第一年我有那个学生，我考很难嘛，对不对？就两个人拿90分吧，那两个人，OK，其中一个人跟我也是跟我3个学期，还有一个是比较文静的、安静的，然后那时候文字也不是很好，language 也不是很好，语言也不是很好，所以写的 proof 就是我跟你们讲的哦，一大堆等于哦，没有写 if then 啊、since 啊、什么 hence 啊，然后我就给他扣、给他扣、给他扣哦，跟各种圈哦。But along the process，他学习哦，他慢慢加字进去哦，他没有加到整句美美的英文字，也不用哦，就至少有一个逻辑在，就是 since 啊、then 啊、therefore 啊，那我就很清楚了，什么跟什么。他在第3年的时候啊，他的 final exam 啊，考过我第一年那个90分的，所以，所以我要讲什么？你在我的班是可以成长的，我不确定别的老师班啊，但是我的班也是可以成长的。OK，成长到什么程度，就看你愿意放多少的 effort 进来，你要多努力，你要做多大的勇气的决定。不要误会啊，我没有讲你一定要做数学家还是什么啊，不是这样的。这个东西你是可以用在各种领域的，各种领域的，你会开拓你的思想，你会想东西不一样去。当你面对一件事情的时候，是不一样的，真的是不一样的。OK，OK，yeah，OK 啊，好，yeah，trick is better。所以我不是要故意扣你分的，你不在我班，我也不想扣你分的，好吧？所以就大家一起学习了，OK，尽量学，尽量学。Any question? Other question? 什么？没有问题。可以啊，懂下一个 assignment 要讲教了吗？要改什么吗？会危险哦，这样有点危险。Um, so, from some of your feedback, seems like you are not fully understand what I say in the lecture. 我也不知道你不会什么，可能你也不知道你不会什么，但是就是说，只要你有一点点觉得不对劲的东西，我希望你就快点来问我，OK，不要用这个不对劲的东西一直做下去，然后才打一个大错给我看，然后我就会很 back check，what's back check？very frustrated，OK， good frustrated，yeah frustrated，OK，因为 if I 就是说在课堂上我们要保持要有效的沟通，所以如果问你啊，你今天答应了星期日交，那你不交，你是不是要跟我讲一下？对吗？你如果搞消失、搞失踪，我怎么办？你也要想想我吧，对不对？就我们大家就保持有效沟通，我可以给你 SM，但是你要保证我一些东西啊，对不对？是不是？所以，我们保持有效沟通啊，OK，yeah，还有什么东西要讲吗？蛮重要的这个东西，因为如果不讲的话，你 assignment 就这样搓到完了，搓下去了。OK，说希望你下个 assignment 呢，based on 这次的 feedback 改掉，OK，改掉那些不应该有的东西，加一些应该有的东西，OK。我不需要你写长长的东西，但是就是 enough to explain what you know，OK。How about we take a break and then we'll start new content later. So let's break until 1:54. 来，军人，可以过来一下吗？ 什么叫 low order infinity？没有听过的。
解释的，就是你把它提出所有的这里
没有 define 过这个东西。
不是，
呀呀，
这个是这个不是我的正面过程的解释啊，是
但是其实解释无效。
就是你把这句话删掉了，
OK，好，删掉。
整个也是
OK，假设我删掉的话，然后接下去是什么东西？
把那个从法里面东西
对，
，S
导出来呀，明白？
就成
也，
那么这个是可以弄的，
啊？为什么？
这个需要成本
哦，对呀，怎么知道？
因为大面比上面大的整个不都是一个这样子的东西，要全部都
我们班上有这么，我知道有些东西是明显，但是就是我们也没有证过，我们也没有用过班上有没有？对呀，对啊，这些东西你都要考虑。我们应该面对吧？对，上课没有讲过的东西要自己找。
但是
嗯，
不理解，就是到一个什么样的一个
对
基准，就是比如说
说，
那个，比如说就是
嗯
比如说我可以把这个
嗯，
这个 A 我可以拿出来，这个东西不需要这个，
对，
是
这个就对
对，但是这个东西现在你是要求我去，或者是我需要证明的东西，
OK，就是说，就是 OK，这么说啊，我做的所有题目不是可以用我教过的东西来做出来的。如果你选择不用我教过的东西做出来，你就要自己证明。如果你看我的答案不是全部是我在班上提过的，我一定 match 了这件事情发生。所以就是说，有一条路是可以用我完全是我自己做的东西做出来的。当然，它可能有其他路走，但是这条路的话，你就要自己走，就是你要证。可能这条路是一些我的东西的延伸，但你就要去说，我其实也有用到这个东西啊，然后我就可以很快用，不需要完全正，你明白吗？
它确实有些问题，但是
对，
我的感觉就是怎么，就是
你说的
对你的要求还是这个主要是对要求
对，
不是很明确，
还是不明确。
对吧？
我刚才说了这么多，你觉得不明确？
就
没事，冷静一点，没事，没有什么。
或者
对
你上课讲的，
对，
在那之外的，
对
我是需要去证明的，但是我现在就是我上来找的那个，你跟我说了嘛，
对，
是那个什么，
但是你没有解决掉那个问题啊，你没有解决掉上次你跟我讲的，
甚至成这
对
只不是去占了他那个去自由球，
对，对
然后你现在问我的是这里，我这个不等式需要证明，
对啊，对啊，我们班上如果我要你用这个东西，不是我会写板，比如说我3个，我会告诉你可以用这个，班上没有讲嘛，
很多时候就是他就是
我就告诉你有一条简单的路，用我们班上能够做的，肯定做得通。但是如果你去选一条不同的路，那你就要过来问我这一步可以用吗？这步可以用吗？这一步可以用吗？你先过来问我的，你可以来问我的啊，不是说你要自己做了教，不是这样，你可以来问我的啊，然后我会告诉你哦，这个东西其实不用啊，或者说不需要这样子啊，或者说能有更简单的路啊，那你就不用多出这些东西哦。如果你觉得这个东西很容易看到，然后你就直接说几句话就好了。但是如果不容易的话，我也看不到，对吗？
这个确实是写的有问题，
嗯， 要
做一个作业，
OK 好，
是这边的话呢，用这个复合性，
不可以，我们都没有教
但是
前面教过的东西是吧？
对啊，
但是 I mean，连那我就问你一个问题，你在这个班学了什么？
微积分就是没有，
为什么你不用这个班能够做到的东西做呢？
其实也有用啊，
没有啊，我班上没有教这个，我班上没有用这种东西啊。
所以说
啊，
使用了一个，
对，
但是我也使用了其他的方法，
我知道，但是就是说我再告诉你嘛，我怎么出题，我怎么出题，然后我要怎么出题，我的答案是怎么样？肯定是用所有我在这个班教过的，找到最终答案，不对？
所以说这个是不行，然后
对，不行。
下面的这个
对，如果你不确定，你就问我，然后我就跟你讲不行，你就换。OK，
这儿呢，这个极限等于一可不可以？就
嗯，
区域没有它等于一，
不可，这个给我猜一下，
这个我觉得
这个如果你真的到可以用，但是其实不需要用到这个东西，也可以也可以 pass by 这个东西，也可以算得到，但是要用另外一个我必刀的，对，但是这个等于一好像不难证，但是就是不能，除非我在班上有用，或者就是说，
其实这个也是我比较困惑的问题。
对，
你刚刚说的用货币打方式，
对，是我班上有用，对不对？
哎，有用，
有用，你要听课，我有用，你来看，我可以指给你看，我是故意的，我故意有用的，所以你要听很清楚我的课，你要读我的 note，不能说你自己看懂了课本就什么这样，因为我们是很精细的，哪里啊？有做笔记的习惯吗？
怎么做？
因为你不做的话，有些东西你会漏掉。确实这些东西就变很重要了。其实有些我允许用，有些不允许用。接手嘛，在这题这一题，在算这一题的时候就用到，我特别提出来写出来的。
需要用到就是课件上没有的前置的知识，得是你上课用过的才能用。
Yes，我就是我上课的时候我不 prove，但是你们可以用了啊，或者我 prove 的你可以用了啊，除非我说那一题我 prove 过，但是我又问你再 prove 一次，那你就要再 prove 一次哦，因为我就是要考你会不会那个，明白？我是说如果你不确定的，你就拿过来问我就可以了，那我就跟你讲这个可以用，这个不可以用，对啊，OK 啊，对。
那个第一道题的就是扣分点在哪？
什么 theorem 我们没有教过吧？什么来着？我不知道，我们不知道，没有在这个课里面。嗯，
然后那个解析几何题，
是什么来着？问题是什么？我也不知道。问题我不知道那个是什么。
啊，那如果不看这个
OK，不看那个，
不看这个，
不看那个，
这个的话是对的。
确实。然后呢？然后这个我不知道在做什么啊，这个我就不知道在做什么，我就是不知道你为什么忽然间看这个东西。嗯，这个为什么看这个哈？因为
就直接抵翻。
你知道为什么这样 define 吗？因为我要符合这个条件，就是说我告诉你说这个是它的 root 嘛，对不对？然后它的 root 会符合这个条件，它的 linear combination 也会符合这个条件，讲这句话，明白我讲什么
那你为什么能想到这里是？
？OK，我再讲一次为什么会想到啊？OK，你看follow the hint，OK，这边全部 follow hint 罢了。然后后来我发现这两个都会符合嘛。如果你考虑 linear algebra 的话，天然就会想看一下它的 linear combination 会不会符合，然后我就放进去算咯，诶，也符合哦。所以意思说，如果我看 linear combination 这个两个 root 的话，power of root 的话，它会符合这个 recursion formula。这样我剩下找什么呢？如果全部 RS 都符合，这样不是很奇怪？但我去查一下它的 base case，如果要符合它 base case 有什么情况？哦，原来 R 和 S 都需要是还是 E over square root 这样子。
你这个不是零要这个东西。
对，零点二九八东西啊。对。
那我们上课也没讲到这个。
I mean，你不要用 linear algebra 来 solve 也可以，你用那个 system of linear equation 哦，就是普通的 solve 哦。但是我现在要问你的是，这个解法为什么会天然成立？就是为什么要看这个方法来解？
对，
下个OK，我扣你几分？我扣你5分，那题几分？哦，8分。OK，你再想一想，，Yeah，怎么扣太多？你也扣太多。你有看到他错什么没？啊，拿中文你乱讲话，中文乱讲话。对啊，为什么这样？为什么这样？
没事，我3分读肯定拿完，3分读就会拿高分了。
I mean 什么问题？干嘛？没有哈。OK，
project 题目，
你如果觉得你有分，你就过来跟我讨。OK，好。Yeah，
这里是你就不能直接这样写，还是你看不懂我在做？
可能我看不懂，等一下你再来找。OK，Yeah，as I say 啊，我不是随便乱扣你分的，如果你不满，你就拿来跟我讨分，不要跟我讲有和没有的东西。我不是随便乱扣分的，如果我真的扣错分，我会还给你的，不用跟我阴阳怪气。我是很不喜欢这样的人。我很讨厌不懂感恩的人，我跟你讲。 对不起啊，我知道你有你的性格，我也是我的性格，但是这个真的是踩我的底线。So if you think that I take off too many marks, you are welcome to talk to me and discuss with me. Is it clear? Okay. If you can convince me, okay, you think that your stuff is correct, then I will give you back the mark. If you are wrong, I took off your marks. I do it consistently. It's not just you that get taken off marks. All of you got taken off. The same way. Don't think about yourself only. This is too selfish. Okay, sorry, I think we should restart. So last time we stopped at this theorem here. So if we have a power series, okay, power series in the form of x minus a with coefficient xn, then this series will converges at this three type of interval. Okay. So how do we determine the convergence of power series? How do we determine the convergence of a power series? There's one test we used last time, which is the ratio test. So we know that by ratio test, the series Cn times x to the minus a to the power n converges if and only if, not if and only if, but there's something that implies this series converge, which we will use ratio test. How do you use ratio test here? So ratio test compare between an plus 1 and an terms. So what's the an terms here? Consider an to be the Cn times x minus a to the power n. Okay. So what's the limit here? Limit of n plus 1 over an is what? We need to make sure that this limit here is less than 1. Is it less than 1? Does it need to require greater than 0 now? What's the statement of ratio test? How many cases you can get? 3 cases. So what's the first cases? Less than 1, and then the ratio is less than 1, then the series absolutely convergent, and then greater than 1 and less than infinity. Huh? Or less than infinity, or equal to infinity. Okay, then the series diverges. Okay, if the limit equals to 1, then the test is inconclusive. Why we don't need to care about L less than 0? Because we care about positive number here only. Okay. So we want to make sure this limit here is less than 1. So what's the computation here? So if we see on the other side, so consider, so let me write down here what we have and what we don't have. We want to make sure that this is less than 1. But what's this calculation here? So by our definition, this is really just Cn plus 1 times x minus a to the power n plus 1 over Cn times x minus a to the power n. And what is this? This is really reducing to the ratio of Cn plus 1 over Cn times x minus a. So if you notice that this term here, okay, there's only really see the coefficient here depending on n. Okay, so you can regard this x minus a as just a constant. Okay, so what can you do? So you can really bring the x minus a out and just consider the limit of Cn plus 1 over Cn. And we want to make sure that we require x minus a times this limit here is equal to L, such that this L is less than 1. Okay. Right. So if you can make sure that this limit is less than 1, then you can make sure that your power series converges. Right. So what? So yeah. Any question so far? No question? Okay. So if you can make sure that this whole thing is less than 1, then your series converges. So remember that last time, what kind of a condition we had last time? There are 3 types of calculation we did last time. Okay, so should we just quickly recall the example we had last time? So let's just quickly recall. Okay, so the first example we have this series here. So we apply ratio test. If you go through this calculation here, you want to make sure that your x is reading what? Reading absolute value reading 2. Okay, so it converges for all the point between -2 and 2 here. Okay, and then from the last terminology that we introduced last time, there's 2 terminology we introduced last time. One is radius, the other is interval. Okay, so what's the radius of this convergence here? Okay, can you see radius of convergence from this calculation or not? Okay, so if you look at this point of convergence here, did you notice that this point is this axis, the interval of this -2 to 2 is centered at 0. Is the middle point 0? Okay, you can see that these 2 endpoint here is symmetric on 0. Okay, then we will say that the length from 0 to 2 is the radius of convergence here. But what's the interval of convergence in this case? Is it open interval from -2 to 2? Not sure. Why not sure? Because if you substitute -2 or 2 back into this calculation here, what do you get? Actually, you get the limit equals to 1. But ratio test tells you that at those points, the test is inconclusive. You don't know whether they converge or not. So you need to check separately on the endpoints. Okay, so you need to check separately on the endpoints. So radius of convergence maybe give you different interval of convergence, because sometimes you might include the endpoints, sometimes no, or sometimes maybe either one. Okay, it could happen. Does it make sense? Okay. Okay. You not believe? So look at this case here. So if you look at this case here, if you check at 2 endpoints here, you observe that there's only one endpoint in converge. The other endpoint it diverges as a harmonic series. So you will write that this series converges on this half open interval here. Okay. Okay. So why is it centered at 0? Because you can see it from this series here. Okay. So what's the shift of this x? So you can note that this x here has no shift. Okay, it's just x. Okay, if there's a shift, you'll see that here is x minus a to the power n. It is centered at a. Okay or not? Okay. So how about the other case? Maybe you get this kind of calculation. Okay, if you use ratio test, what do you get here? If you try to make sure this limit here is less than 1, what can you see here? You can see that the limit of this Cn plus 1 over Cn actually go to 0. Go to 0. So meaning what? No matter what point you put that you multiply with this 0, surely you will have this inequality less than 1. So it is true for all point in R here. Okay or no? Okay. So this is the other case when the convergence is a whole real line. And one more cases is this case where your convergence is only 1 point. So what happens here? If you look at the limit of Cn plus 1 over Cn here, this limit here will diverge. But you still want to make sure the whole limit less than 1. You have a freedom here because you are free to choose the point there. Okay, so if you pick the point to be 0, obviously anything times 0 should be 0. So I think maybe from here you have one question, right? How about 0 times infinity? Usually 0 times infinity is not defined. Okay, it's not defined. But to make this precise, I think we need to have further analysis. Okay, actually you cannot understand at 0 times infinity. Because if it is 0 times infinity, how do you know it's whether 0 or infinity? Not sure. I mean, you cannot understand infinity as a real number. Okay, so you need to do some analysis there. Okay. Yeah. Okay or not? So really, what happened here, I can imagine is you take limit of this whole thing here. It's not okay. Let me write it more clearer. So instead of thinking this limit like this, you should think of it like limit. Sorry, maybe use the other color. Limit of n to infinity of n plus 1 times the absolute value of x like this. So if you pick x to be 0, what happens? You just really look at limit of 0. Okay, so you need to look it in the right way. Okay, does it make sense? Okay, so don't take this point out first. You consider the right sequence. Okay, any question? So these are the 3 main cases you will get for this convergence of power series. But during this calculation, right, can you try and figure out what's the relation between radius of convergence uh, with this ratio test calculation? You see some pattern or not? You see any pattern? Why this radius is 0? And then why the above is radius is infinity? Can you sort of see from this calculation? Maybe let's bring some cases. Let's bring these cases together. So let's bring these cases together. So let's copy. Change the color. No change. This is the first calculation we had just now. And then we have a second calculation just now. And the third calculation just now. Okay, so in these cases, so first cases we have r equals to 2. So let's put the 3 over here. Here I put r equals to infinity. And then here is r equals to 0. Okay, so can you observe a pattern? So what pattern I want to observe here? So can you look at the limit of n to infinity of Cn plus 1 over Cn with this number or not? Can you see any pattern or not? Let's call this L. Can you see this pattern? So where's this Cn plus 1 over Cn in each cases? You can see it here, and see it here. You see any pattern? So in first case here, we really got 1 over 2. In second cases here, what do you get? You get 0. And then the other cases here, what do you get? You get, what do you get? I get something wrong. What's going on here? Why are these two the same thing? So I'm copying the wrong thing, is it? So let me see. What's the thing I want to copy here? So this is the thing I want to copy. So n plus 1. Okay, let's remember this, n plus 1. So let's remove this. So I'll just replace this by n plus 1. Okay, n plus 1 here. So what is this? This is really infinity times x. Okay. So can you relate this 3 limit here to the radius that you get on? Can you see any pattern? See any pattern here? So you get a half here, but your radius is 2. You get a infinity here, but your radius is 0. You get a 0 here, but your radius is 6. Can you deduce anything or not? What can you deduce? If you know about the limit of Cn plus 1 over Cn, can you deduce anything about this radius here? Idea? The radius is just 1 over L. Is it 1 over L? Why is it 1 over L? What did you do when you want to find the radius? You move the limit to the other side. But if you move to your limit to the other side, how do you move it? You divide by L. Okay or not? Okay. So I mean, in the previous calculation, right, we should be able to see this already. Correct or not? So if I want to make sure this calculation is less than 1, what do? You simply move your limit to the other side. Okay? You move your limit to the other side. And then you can show that if your x minus a is within this length here, then your power series will converge. Okay, does it make sense? Okay, so this 1 over this limit here become your radius of convergence. Okay, radius of convergence. So if you have sorry, I think we need to keep this modulus. So if you have this power series center at different radius, a different center, then you take radius r away from this a from both sides. Does it make sense or not? Does it make sense? Do you know how to read this inequality here? Maybe let me make some spaces. Make some spaces. So this implies what? This implies that x minus a is less than r greater than minus r. But what does this mean then? This really means that x is in between a plus r greater than a minus r. I think it's very hard to think about this inequality. But if you try and draw this inequality out, what do you get? The picture you get is this. So you have all the point that is r away from x, sorry, r away from r, sorry, r away from a, and then minus r away from a. Yeah. So all your x will lies inside here. So this is a interval around a. Does it make sense? Okay. Yeah. So let's continue. So let's continue do some exercise on finding the interval of convergence and radius of convergence. So let's find the interval of convergence. Sorry, let's use and the radius convergence of the foreign series. String to n, x to the n, of the square root n plus 1. So what do you see first? So whenever we ask this question, right, you should check that this is a power series, okay? Because I never taught you other series to find this radius of convergence. So what's this power series here? What's the Cn here in particular? So if you rewrite this series, you could split out the coefficient Cn and the monomial. Okay. So what do? You want to make sure that this series converge. There's really one way we taught in this class for now. Okay, we will use ratio test. Because why we use ratio test? Ratio test will have some bound, some control on the x that you can take. Okay, if you use other tests, maybe you can show that it converges, but you're not sure where it converges. Okay, but by using ratio test, remember that you can get some bound on your x. Okay, so by ratio test, when the series converge, so the series converges if what? If you can make sure that you have the ratio test condition. Okay, so you want to make sure that your an plus 1. Okay, so an plus 1, you need to include your monomial in. So you will have n plus 2 to the power n plus 1 times s to the n plus 1 over what? Minus 3 to the power n x to the n over square root of n plus 1 here. Okay, you want to make sure that this limit here is less than 1. Okay, so you know how to compute this? So if this happened here, so the series converge if this happened. So when does this happen? So how to make sure this happen? So what's this calculation here? So if this happen, then this converges. So let's compute this. So consider E of this whole thing here. So this whole thing here equals to what? What is it equal to? Is anyone calculating? Square root of n plus 1 over n plus 2 times 3 times the absolute value of x. Okay. So we want to make sure that this is less than 1. So that this limit here is less than 1. But what does it mean here? So what this limit here? What's the square root of n plus 1 over n plus 2? What's this here? How to compute this limit here? This is what? It's just 1. Good. Because should we go through or are you okay with it? This is equal to 1. Okay, do you know how to compute? So you divide n throughout, okay, and then you will see that 1 over n and 2 over n converge to 0. So you get square root 1. So in this case here, what do you get? You get that modulus of x is less than 1 over 3. So this implies what? This implies that our radius of convergence is 1 over 3. Okay. But does this imply that our interval of convergence is -3, -1 over 3 to 1 over 3 or not? Is it true? We deduce like this because here is strictly less than 1 over 3, correct? No? Can we deduce like this or not? No. Why? We need to check at the endpoint. What happened? What happened if I sub 1 over 3 inside here? The limit I get is equals to 1. But the ratio test says what? We're not sure whether at the endpoint it converge or diverge. So we need to check separately. Okay, so we need to check separately. So we need to check at both points here. So at x equals to 1 over 3, what happens? And we also have to check that what happens at x equals to minus 1 over 3. So checking at x equals to 1 over 3, meaning we just sub x as 1 over 3. 3 to n, 3 to n over square root n plus 1. Okay, so what's this calculation here? So this is the sum from 0 to infinity of minus 1 to the power n of the square root n plus 1. So what kind of series is this? What kind of series is this? What type of series is this? Alternating series. So you can try and check whether alternating series test work or not. Okay. So alternating series test, how many conditions you need to check? How many conditions you need to check for alternating series test? How many conditions? 2, right? So what's the first condition you need to check? You want to make sure all the term is decreasing, okay? And then second condition, you have to make sure that the term converge to 0. Okay, not just decreasing, you have to decrease to 0. Okay, but the term that we consider, do we need to consider the alternating sign or not? No, right? Okay, so we just consider the alternating Bn. So what's the Bn here? So we can set Bn to be 1 over square root n plus 1. Then first we see that 1 over square root n is greater or equal to square root n plus 1. Second, this one is true for all n, right? Second, what do we get? Second, we straight away check the limit of 1 over square root n plus 1, which is 0. So it satisfies the two conditions of NST, so we can conclude that by AST, the series converges. How about the other endpoint here? Okay, let's look at the other endpoint here. So the other endpoint we're left with 1 over square root n plus 1. What is 1 over square root n plus 1 here? Okay, if you are not clear, maybe we can rewrite this series here. Okay, I mean, if you're not sure why I can rewrite, you just list down what's this series here. So what's the first term here? You can see that it is 1 over square root 1 plus 1 over square root 2 plus 1 over square root 3 and so on. So really, we can rewrite this series from n equals to 1 to infinity of square root n. Do you recognize anything? What's this? P series, correct or not? What P is this? This P is n to the half. Okay. So this P series here has P less than 1, meaning this P series will diverges. Okay, as it is P series, as it is a P series with P less than or equal to 1. Okay, so when does P series converge? As you, when does P series converge? When it's strictly greater than 1. Okay, and if and only if. So that's really you need greater than 1. Okay, good. So there are 2 endpoints here. Okay, only so let me put down the conclusion here. So the interval of convergence, okay, of the series, I don't want to write down the series, is what? Is a closed interval from minus 1 over 3 to open interval 1 over 3. Okay. Let's see. Okay, so far any question on finding radius and interval of convergence? Any problem? Okay. Why closer? Where we converge? Okay. We close at a different endpoint. So we did 1 over 3 first. Thank you. Yeah. Sorry. We do in a different order. Okay. Okay. Yeah. Any question? Okay. Let's see. I think there's one more exercise. Maybe I just leave it for you to do it. I will provide the solution after the class. Right, so there are 10 more minutes. Maybe let's go to one new topic first. So let's go to the next part. So this is the representation of function as a series. Okay, so we're gonna remember one example here. So which is the geometric series. Okay. So with this word, right? Can you like imagine what this word trying to say? You want to represent some function, okay, using power series. And there's one case you know very well actually, whereas repeatedly talking about these cases, even we start the series chapter. That is 1 over 1 minus x. You can write this as a the most simple power series. The most simple power series with coefficient 1. Okay. So when this quite restrictive, if you want to write this equalities here, this is only true when this is only true when x is strictly in between 1 and -1. Okay. Only then these sum to infinity works. Okay, you should remember all the different way to call this equalities here. Okay. But we can make use of this to find the representation of other functions. Okay, find representation for other function as a power series. So for example, 1 over 1 plus x squared. Okay, we're gonna use what we know, okay, to express a new function in terms of power series. Can you see some similarity between these two functions? Okay, both of them are a reciprocal of something. Okay, but the differences here is about this 1 plus a. Okay, one is minus x, one is plus x squared. Okay, is it possible? Okay, is it possible to make 1 over 1 plus x squared to some form of 1 over 1 minus x? How? How? Sure. So obviously you need to produce a minus sign first. Okay. Then what you're taking away is x to the negative x squared. Okay. So meaning what? You are somewhat doing what? Substitution. Change of variable. Okay, change of variable. So if you change the variable here to minus x squared here, you should change all the x's. Okay, if you change all the x's, what do you get? It's really just sum from n to 0 to infinity of minus x squared to the power n. What is this? This is really just alternating x to the 2n. But be aware, this substitution only true for limited cases. Why? Because the equality you use above here only true when x is less than 1. The modulus x is less than 1. But now, what happens? You make this x into a negative x squared. So you need to re-evaluate what x could satisfy it. So meaning what? Meaning this equation true only for the absolute value of minus x to the square is less than 1. Now when is this true? So let's reduce these cases to just x. Okay, so you need to make sure that x squared is less than 1. Okay. Can you further reduce or not? X squared is already positive, so we can remove modulus. Okay, but when does a number square is less than 1? Can you imagine or not? Did you know? Maybe just pick any x to try first. When x equals to 1, what happens? It's impossible that you can square to less than 1, right? If any x greater than 1, also not possible, right? When you square, it is increasing. But there's one region it is possible, which is all the point from 1 minus 1 to 1. Okay, obviously, these need some proof, but can you just see by verifying for now? Yeah. Is it clear? Yeah. Yeah. So I prove to you it's like by cases. But I mean, yeah. So like this kind of case, if I skip it, then you also can skip it. Yeah. But just that you need to check with me. Because sometimes I speak in mouth, I forgot to write it down. Yeah. Then you need to check with me. So better every time you just come and check with me. Yeah. Okay. Don't assume that I don't do it, then you don't do it. I know this is the social norm, but I try to avoid this norm. Okay. Yeah. I can make mistake one. Okay, I'm not God. Okay, I'm not God. Don't treat me like a God. Okay. So next one. How about this function here? 1 over x plus 2. Okay, so I think you already observed that we can do a similar trick here. Okay, so what sort of similar trick we can do here? Now there's a cumbersome tool there. Can I remove it? How to remove it? There's a cumbersome tool there. How to remove it? How to make 2 into a 1? Divide by 2. Okay, so meaning what? I want to pull out the 2 from the denominator. Then what do I left with? It's just 1 plus x squared. Sorry, x to the power x over 2. Then we somehow go back to a similar case as just now, where we just do substitution of minus x to the 2. So we will do similar thing like just now. We just take the power series of the geometry series. Okay, we sub it by minus x over 2 to the power n. But remember, whenever we do this, what's the main thing we need to take care here? This equality here only true for what case? For absolute value of x over 2 is less than 1. So meaning what? Meaning that it is true when the absolute value of x is less than 2. Or somewhat this radius of convergence become larger. Okay, become larger. Okay, so I think that's all. So you can write out the sum maybe more complete like this. So make minus x to the power n over 2 to the. Okay. So we know that this is the radius of convergence. Do you know about the interval of convergence? Can you deduce something about interval of convergence? You need to check endpoint. Maybe you need to check, but I think we check it for geometry series before. Okay, so it is strict. It is actually really strictly between minus 2 and 2. Okay, you should check, but I think we checked it before for geometry series. If you don't believe, go and check the endpoint. Ask whether at minus 2 or at 2 diverge. Okay. I believe when we prove the convergence, we check the endpoint. Let me put a comment here. Otherwise, try and check convergence at 2 and 2. Okay, we have checked it for geometry series. Sorry, too squeezy. Check it. Series. Okay. Right. I think we run out of time. Maybe we continue tomorrow. No, Friday. Okay. So for like Xiaopeng and Hambo. Okay, maybe I take a photo first. I need to do attendance. Okay, so Hambo, Xiaopeng, or any others want to take? I want to chat about your marks. You can come and discuss with me. We go to the meeting room. We can discuss. And then Jing Yan, right? Jing Yan, yeah, please come and see me. So I'll see you on Friday morning.